You guys ready to learn about generators? Yeah. I'm ready to talk about generators. So, if you want to follow along, I've got some slides, GitHub/laser/slides. I had some totally lame GitHub name, and I was told by someone that if you email like contact@github.com, they'll totally like respond and do stuff. So I emailed them and asked them if I could have laser, because whomever was sitting on it wasn't doing anything with it. They totally gave it to me. So reach for your dreams. You might be able to get laser 2 or something like that. If you can't be bothered to sit here and watch me go through all these slides, I've got some working demos of the generator stuff up at es6-gen.herokuapp.com. You can use these examples with the current version of Chrome as long as you enable the experimental ES6 features. Firefox, as of Firefox 27, has a promises implementation that works with, excuse me, not promises, I've been sitting in too many other people's talks today. Generators implementation that'll work with all but one of the examples I have here. There's some discrepancy between how I think they deal with the yield keyword, but it should more or less work, and you can sort of get a feel for some trivial examples of using generators. So I'm a developer at Carbon 5. There's some other Carbon 5 people around here. Yeah. I'm based out of the LA office. I'm from a little hillbilly town outside of Seattle. Whenever I come to San Francisco, I always love to like take digs on LA to try to like, engender support. So I just want to let you guys know that I say hella often. Anyways, okay. So what am I going to actually talk about? Essentially, the value proposition that I think generators provide, amongst others, but the main one for me, is it enables you to take code that looks like this, which is kind of sloppy, lame JavaScript, but it's doing a bunch of things that we do often. Try-catch used to trap errors that arise from performing some synchronous operations, using a closure and a centralized error handler to consolidate error handling across, let's say, event loop ticks as a result of some like asynchronous operation gone awry or whatever. Anyways, we do this stuff all the time. Flow control by nesting continuations inside of continuations, blah, 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 blah. You can take that code and you can condense it down to something that looks like this. We're doing basically the same thing. We're going to perform a synchronous operation, some lib.getData. If some exception were to arise from that, let's say some lib was undefined, we called getData on there, we're going to hit our catch block. Similarly, if we get an error passed to our callback to get or post, which is, let's just assume, is like an alias for some, I don't know, HTTP get request to /foo or post to /bar. If we get an error there, it is going to hit our same try-catch, and generators enable you to write code that looks like this. So you're going to be able to move from a continuation passing style, where you're like asking the computer to do something and at the same time telling it what you want to do next, to direct style, which is asking the computer to do something, getting a value back, maybe putting in a variable or whatever, and just moving sequentially through your program without actually losing any of the excellent aspects of the single-threaded event loop. Okay, so that was kind of like hand-wavy, but really what I'm going to talk about, I'm going to try to demonstrate that I think that programming around asynchronous callbacks is hard, especially for people coming from programming languages that the idioms involve like direct style programming. So I work with people that have Java backgrounds, have Ruby backgrounds, Python, and over the last 5 years I've seen people transition into doing more JavaScript development, especially on the client, and it's proven difficult for many people to move into that continuation passing style paradigm. As I mentioned before, ECMAScript 6, you get generators, so you can do some interesting things syntactically to alleviate some of the pain of learning how to write code around asynchronous callbacks. Okay, so in demonstrating how awesome generators are, I'm going to sort of enumerate some gripes that I have about programming with asynchronous callbacks. The first one being, as I mentioned, that I think it's a non-trivial amount of effort for someone coming into the language programming with this asynchronous callbacks to follow what's going on. So we're all JavaScript experts, so we know that code is total bullshit, but like I committed this sin early on, right? Like you write your program in many other languages from top to bottom, Here we have message variable that's accessible to the closure, this anonymous function expression here. So when I get a response back from making an HP request to profile, I'm going to enqueue my callback. My callback is going to fire. I'm going to add profile.name to whatever already exists at message, and then I'm going to log it out. No, that's not true. The var message hello and console log message happen in the same tick of the event loop. Future tick of the event loop is when I'm going to do the assignment to message, which is available through the closure. So I'm actually going to log hello and then nothing else after that, which is, kind of a bummer. As I said, you guys all know how to do JavaScript, so this is not like an error that you make anymore. But if you try to teach your mom how to write JavaScript, she may have some questions for you. The other thing I want to talk about is handling exceptions across different ticks of the event loop. So as we know, try-catch only works if the code inside the if the error is raised from code that executes synchronously inside those try braces. So for instance, if like some lib.getData, if some exception is raised there, I'll be able to catch it here in my catch block. And if I want to consolidate the way that I handle errors across these different ticks of the event loop, both asynchronous and synchronous, I'm going to need to do something clever like create an error handler function, which is going to be made available to the asynchronous stuff through a closure. So let's say I get an error back from either one of my asynchronous calls to get or post, which, like I said, is just an alias for like HTTP GET with an asynchronously fired function expression afterwards. I get an error back. I'm going to, via a closure, send that error to my centralized exception handler. That's a lot of noise, and I will demonstrate that it doesn't have to be this bad. The last thing is that it's my position that flow control, especially if you're mixing parallel and things that you want to do in series, is harder than it needs to be when working with asynchronous callbacks. This is just the vanilla JavaScript example, but what we're doing here is we're doing an HTTP request for token and an HTTP request to get a key. We're doing those two things concurrently. When they're both done, then we're going to execute our login function, which is going to take those two values, it's going to combine them into an array, and we're going to send all that stuff via HTTP post. Once we get a response back from that, then we're going to redirect the user using some auth key or something like that. It's a lot of code. And the continuation, or the callback that we're giving to our two get functions, in order to achieve this notion of like blocking further operations until both of these asynchronous things have completed, I had to do some lame stuff to check to make sure that when one asynchronous operation completed, the other one was completed, so on and so forth. This gets a little bit better if you use promises, but it's still a lot of noise, right? We can use your favorite promise library of the week to do two HTTP requests, one for token, one for key. And then when both of those two promises have resolved with a value, we will execute our anonymous function expression here to do an HTTP post to auth using that data. And then when that thing is done, then we can do our redirect. That's better. I mean, it's better than that sloppy stuff, but it's not as good as we can do. Async, there's a lot of code here. How many of you have used async? Many of you, right? Yeah, I use it all the time. With async, we're doing the same thing. We're doing a get to token, a get to key, we get the results back, we do a post, and then we do a window redirect. We can cut some of the lines out of this by using bind to do some partial applications so that we just pass a reference to the original function with some arguments partially applied, but it is still a whole bunch of code, and to the uninitiated, you have to look at all this stuff like parallel, waterfall, whatever. It's a bummer. Okay, so generators. Generators are being spec'd out in the ES6 specification, or being described in the ES6 specification. I'm not going to read you that, but they're essentially, they are functions with multiple entry points. So the functions that you've been working with in JavaScript up to this point, you enter in at the top, and you exit out at the bottom. These ones, you enter into the top, you can stop, freeze the generator function somewhere in the function body, and then resume it later on at the point in which you suspended. You may be thinking to yourself, like, ECMAScript 6, that's awesome, but like I have a job that caused me to like, write code for old web browsers or whatever, and I totally get that. You can begin to play with these things, and you can actually make this stuff work with ES5 compliant browsers if you're willing to introduce a transpilation step. This Google Traceur, I don't know how to say it, but the Google T word project enables you to write some code that takes advantage of some of these ES6 features and transpile it into ES5. And since like pre-compilation steps in JavaScript land are like all, like the normal thing we do, it's not, if you transpile to ES5, it's not gonna be that big of a deal. You can use this stuff today in Firefox 27, Chrome Canary, or even the Chrome that, the regular consumer Chrome, as long as you're willing to flip on that ES6 experimental flag. You can use this stuff in Node 11 and more recent as long as you use the Harmony flag. That may not actually be true. You may not need the Harmony flag anymore, but as of 0.11, you can play around with this stuff. Okay, basics. This is like the hello world of JavaScript generator functions, and I'm going to go through a couple like pretty lame examples just to make sure that you understand how we're bouncing back and forth between a generator function and the code that calls the generator function. So it may be super simple, and you may already know how to do this, but just bear with me. Speaking of, quick show of hands. Have any of you used fibers in Node land? Yeah? All right. Okay, so you already know everything I'm about to talk about. You can leave. Just kidding. Okay, so a couple new things that we're seeing here in this generator function on the left-hand side of the screen. There's a little asterisk next to the word function, which denotes a generator function, which is a different type of function than you're used to. You're also going to notice a yield keyword. Exactly what those things do will become self-evident in a moment here, but the asterisk, things to remember, asterisk means generator function. Yield keyword is the point in which your generator function is going to be able to suspend and be resumed. If a yield keyword exists in the body, the function body that is not a generator function, you're going to get an error from your browser. So at least they help you out there. You can't accidentally shoot yourself in the foot as bad as you might think with, for instance, with like Node fibers. Okay, so generator function definition on the left-hand side and the code that's going to interact with the generator function on the right-hand side. You can imagine these two things are like on top of each other, but that's not how they orient projector screens, so bear with me. Okay, first thing we're going to do, we're going to call our generator function. So what that's going to do is it's going to give me back an object that is a generator object. We haven't actually started evaluating the code in the generator function yet. That generator object, I'm going to store it in this seq variable. The generator function, as I mentioned, we haven't started going into that code yet until I call the next method on that generator object. That's going to start executing the code from top to bottom. So I'm going to do my variable declaration A, B, and C. I'm going to do some assignment 0, 1, 0. I'm going to hit this while. I'm going to enter into this while block until I find the yield keyword. Once you hit a yield keyword in a generator, what the computer is going to do is it's going to evaluate down the expression as far as it can on the right-hand side. In this case, it's just A, and then it's going to suspend the generator function at the point right after like the yield and its expression. And it's going to freeze. It's just going to stop. What it's going to do is it's going to make available as the value property of the thing that is returned from calling next, the value that was yielded from the generator function. So sort of doing the mental substitution, and you can tell because I drew a little line through it, so you're doing some substitution here. The first thing that we yield is the value 0. We go down to the next line, and when we call next, we resume the generator function immediately after that yield keyword and its expression. So then we go down, we do some more assignment, we hit our while loop again, we hit our yield again, and then now we yield the new value of the expression on the right-hand side of yield, which is going to be 1. Generator function is suspended again, waiting for somebody to call next on it. So you can sort of do like the mental exercise of figuring out where we're going to go here. We're generating an infinite sequence of numbers lazily, which is the sequence of Fibonacci numbers. Okay, so I was talking about multiple entry points. We saw in the prior example how the caller of the generator, the generator function is receiving values yielded to it. You can also go the other direction. So before I go any farther, pop quiz, let's assume that log is an alias to console.log. What do you think we're going to see in the console if we run that code? You can just shout it out if you feel empowered. And I'm not going any further until somebody guesses. A. You're close. Yes. All right. Well, you were partially correct. 42. You are not correct. That's okay though. We'll learn the answer together. Okay. So first thing we're going to do, we're going to call our generator function, which is going to give us back a generator object. We haven't started evaluating any of the code here. We've got in G, we've got a reference to this generator object. We call next on it, which, as you all know, causes the code inside the function body to start being evaluated from wherever we left off. In this case, we never entered it, so it's going to be the top. We're going to do our variable declaration, so we've declared result, and then we're just going to follow the order of operations in the language. We're going to hit this math.pow, and the way the JavaScript is going to work is it's going to reduce down nested expressions as far as they can. First thing that's going to happen is we're going to hit our yield keyword, and we're going to yield the string A back to our caller, which is going to, again, be made available by dereferencing the value property of this return thing that we get back from our generator yielding. And then the POW generator suspends. So the first thing we're going to log out to the console is A. So that was good. That was good. Now, we're going to resume the generator function, but in this time, instead of calling the next method and passing nothing, we're going to pass 10. And this is key if you want to build something that allows you to really communicate back and forth between generator functions and their callers. So 10 here is going to be substituted in immediately where I resume the generator function. So 10, you can imagine, is inserted here after where we used to have this yield A. Then we evaluate the rest of this expression. We're going to hit a yield keyword. We're going to evaluate the expression on the right-hand side all the way down as far as we can, and then we're going to suspend the generator function again. So the next thing we've got logged out to the console is B. And you can kind of see where we're going here. The last time we iterate with the generator function, we're going to call the next method, and we're going to pass 2, which you can see substitutes in 2 for where yield B was. And then we're going to evaluate math.pow. We're going to store the result in the result variable, and then we're going to return it. So finally, you get 100. So you can sort of see how you're bouncing back and forth between the code that's calling the generator and the generator function body, both sending values and receiving them from the generator function. What's up?
I have a stupid question. What do you if you call g.next again?
If you call g.next again, you're going to get an error. The generator object has some properties that you can interrogate to figure out like if it is in a state that you can resume or like start it up again. I believe the property is finished, but the fact that I said believe means I'm probably full of shit. But the specification actually does talk about that. Okay, so Fibonacci sequences are all great and yielding, you know, math and all that stuff. It's cool, but like we want to actually build some real stuff with this. I promised that we would alleviate the pain of programming around asynchronous callbacks, and so we're gonna do that. Okay, so I was whining about the path of execution through a program that is constructed around asynchronous callbacks. This is what we can do if we use generators. There's some differences here. The implementation of our get function has not changed. It's still issuing an HTTP request. It will still cause the browser to issue an XHR to this /profile URL, and it still expects you to pass a callback. What we're doing is we're going to build together, stepping through these slides, a little baby framework that manages this whole bouncing back and forth between our generator function, which we want to sort of look and feel like it were to be using some direct style programming with the library that manages it all. So you're seeing the sync function here. This is something that we actually implement. The sync function takes a generator function as its only argument. So in this case, it's going to be an anonymous function expression, which is just your function with a little star there. It's going to immediately call the generator function, which is going to initialize it and start it running, or excuse me, it's going to initialize it, and it's going to pass it a reference to our resume function. This is all a little weird, but this resume function via a closure has a reference to the generator object itself. And what this allows us to do is pass this resume function to all of our asynchronous operations as the callback to execute, And what that means is when the asynchronous operation completes, our generator function will resume with the value that we are passed. If that makes any sense. We'll step through it a little bit, but this is bouncing back and forth thing that we're talking about. Once again, I mentioned this iterable.next. This is how you send a value back to the generator that is suspended. So you can imagine if this resume function is passed as the callback to execute to my asynchronous operation that does like an HTTP request to foo, when the foo callback gets executed, which is going to be this resume, if I get a value back, like whatever the HTTP response was, I'm going to resume my generator function body passing in foo. Okay, so the other thing that you can do is manage error handling across different event loop ticks. So in spite of the fact that like some of the errors may be made available as the error argument to your asynchronous callbacks, you can consolidate all that stuff and handle it in the same place as your synchronous error handling code, which would be in a catch block. So this is like the state of the union today. Your catch block references this on-error function, and your asynchronous callbacks reference this on-error function. It's kind of lame. You can shrink it all down into something that looks like this. So once again, if some lib.getData, a synchronous operation, causes something to blow up, we can catch it in that block. Now, if the asynchronous callback gets past an error as a result of our HTTP post to foo or our post to bar, we're going to be able to trap that in our catch block just as if it were a synchronous operation. And we can do that with a slight modification to our framework code, which is this sync function that we're building. Okay, so this resume function I was mentioning, this is a thing that we pass our asynchronous operation to use as its callback. What we're going to do is, assuming that our asynchronous operations callback is using this node-style error first and then return value thing, which not all of your asynchronous callbacks are going to be in this form, but for the sake of this demo, just suspend judgment of my code samples. If we have an error, we're going to be able to resume the generator function not with next, but with raise. And what that's going to do is it's going to resume execution of the code in the generator function body, immediately raising whatever we pass to this raise method, which is going to allow us to use the catch block that we were using just for the synchronous operations. So we don't have to do anything clever with error checking and plumbing via this closure, a reference to our centralized error handler thing. We rely on the framework to rethrow that thing for us, essentially. And the last thing is flow control. So mixing the doing two things at one time with doing one thing and then one thing and then one thing is kind of a pain in the butt. The vanilla JavaScript example shows my super strawman version of this. Promises and so on and so forth clean it up a little bit, but it's still not as good as it can be with generators. There's a slight modification to this code that is worth mentioning. Once upon a time, in all the other examples, our asynchronous operations were being passed a reference to this resume function, right? Now, what's happening is the resume function, in order to achieve this, this ability to do two things at one time, is actually a reference to a function that the generator function body needs to call, which is going to return a function that your asynchronous operation is going to use as its callback. The details of which I'll explain in a second, but just do that, make a note of that, because now when we get into the modification we need to make to this resume function, it'll make a little bit of sense. So before, that resume function immediately, when your asynchronous callback was done and the callback that it was passed fired, would resume your generator function with the value that it was passed. But what if we want to do like 5 things at a time? We don't want to resume our generator function until all 5 of those things have completed if we want to get something that looks like what we're seeing here, where we do a HTTP request to token and a post to key. The way that this works is every time you call resume, we increment a counter. And the framework keeps track of how many counters there are outstanding. When you decrement the counter by virtue of your asynchronous operation completing, we'll check to see if no counters are left outstanding. When we've got everything back, then we resume your generator function, which allows you to do things like resume the generator function faulting in an array, which will contain both of these 2 values. So I'll walk you through exactly how that works. First thing we're going to do, our sync function is going to initialize our generator function. It's going to call next on it, which is going to start the evaluation from top to bottom. We're going to hit our yield keyword, and we're going to start reducing down the expression on the right-hand side. So this array that I'm using here is a trick to force the stuff inside of it to evaluate before we actually suspend the generator function. There are a ton of libraries that do this stuff for you. This is just, these demos are for you to understand like how they sort of work at a superficial level. So bear with me. In reducing this expression down, we're going to hit this array, and we're going to evaluate the left thing first. The left thing is also an expression that needs to be reduced. So this is going to be our call to our get function. Get is actually being passed a reference to this resume, the execution of this resume function. So we're going to call resume, which is going to get us back a function, which we then pass to get. Get, like many other asynchronous operations, like jQuery's get or whatever, return undefined. They don't have a return value because they expect you to pass them a callback. We haven't suspended the generator function yet because we need to evaluate the expression in the second item of the array. So we do the same thing. Res, we call it, which is going to increment a counter in our framework and return us a function that we're going to pass as our callback, and then we're going to do our post. So the generator function has still not suspended, but now we've got two asynchronous operations that are like out there waiting for their data to come back. Then we suspend the generator function, and we only resume when both of those two operations have completed. And what the framework is going to do is it's going to substitute back into our generator function an array that contains both items that are the results of our two asynchronous operations. So you can get this sort of feel of doing two things at one time or doing 5 things at one time and then moving down to do the next thing. You can be super expressive with very few lines of code. You leave all that stuff up to the framework to do for you and keep that out of your userland code. We're doing the same thing here. We've already completed these two asynchronous operations up above. Now we're going to do the same thing where we reduce our resume call to a function that we pass our post. We suspend the generator function. When we get some data back, we can substitute that in here. It gets assigned to auth, and then we redirect to a different location. So anyway, so the whole point of this was to demonstrate that generators allow you to do some direct style programming in a world in which like we've gotten pretty accustomed to programming in continuation passing style, which is like asking the computer to do something and then giving it a continuation or a callback to execute when the asynchronous operation completes. You can already use this stuff in Chrome, Canary, Node 011, and Firefox, and also ES5 compliant browsers as long as you're willing to do the transpilation step. It is my position that the adoption of this stuff is going to change the shape of the code that we're writing. It is my hope that the additional complexity in including this framework to do this stuff, or including a framework to do this stuff, is going to be worth the learning curve benefit that you're going to get when you try to teach people how to program in this environment. Hopefully, it'll flatten that out a little bit. So I encourage you to go experiment. There are tons of blog posts online about this. Toby Ho is a guy who's been writing about generators and coroutines in JavaScript since 2009 or 2010, since way back when. Tim Caswell and Andy Wingo on the V8 team all have really interesting things to say about this stuff, especially Andy Wingo talks about the implementation. So I encourage you to go check it out. Follow me on Twitter. I'm Lazericus, because Laser was taken, kind of a bummer. And go check out the code examples and play around with this stuff. Check it out. That's it. All right, what do you got? The question was, like, when are we going to be able to use this stuff in the browser? I mean, like I was saying before, if you're fine with the transpilation step, then you can start using it now. If you are asking, like, when will the ES6 specification be finalized, I'm not totally sure. I know that, like, it's not going to be too much longer. The real question is, like, when are all browsers that people use going to support this stuff? That could be a while from now. So I think the more common use case will probably be on the server side, where the runtime is, like, controlled. But I think it's going to happen pretty soon. I know that the Express guy, TJ, is already working with generators right now. So there are some people thinking about this stuff. And the combination of generators and promises is like a new sort of thing that I think Bluebird is taking on, and the CO library and stuff like that. So people are already starting to work with it, especially on the Node side. Yeah, the question was, are there any performance implications? It will depend on the runtime, exactly like what the performance implications are. Andy Wingo talks about that a little bit in a blog post that he wrote within the last like couple years. And he said the same thing that like I hear all the time, which is a little hand wavy, which is like if you're using this stuff to, if you were writing an IO intensive application, then you know it's not going to be the bottleneck. But there was a comparison that he made, and the results were like almost negligible. Once you're like from the perspective of CPU time, it was negligible. But I like again, he's speaking specifically about V8, and I don't know what it's going to look like for Mozilla's stuff or Safari or whatever. But I think it'll be negligible. I think the real cost will be involving a framework that does the stuff that we just sort of like did with our sync function, relying on something like that and just hoping that like they don't screw it up for you is going to be the bigger hit, I think. Yes, sorry, I usually am pretty good about mentioning that. There are a variety of frameworks that do the sorts of things that I was demonstrating with that sync function, only like in a 400-line version of it that's robust and not my 10-line version of it that sucks. Co is one of them. GenRun, Jenny. I believe Bluebird now has a version of this that works with asynchronous functions that return promises, which is a really interesting thing. One thing that I glazed over in these slides was that the signature for the asynchronous callback that all of these things are using adheres to error first and then return value. Well, that isn't always the case. And there's no specification that says that you have to do it that way, right? Promises are interesting because they provide a unified interface for dealing with asynchronicity, so you can write a framework that can rely on that consistency. As long as these asynchronous operations are returning promises, then you can build a framework that knows exactly how to interact with that kind of code. So yeah, Bluebird is one that does that, and also task.js, which is an older Mozilla project. I'll put some links in the presentation in case you want to like poke through some of the frameworks. It's pretty interesting to learn how this stuff works by like trying to reverse engineer the framework code also, in my opinion. Yeah, totally. Cool. Thank you, everyone.